Today we're going to teach you how to solve systems of equations involving 3 or more variables. No? And we're going to use the Gauss's elimination method, otherwise known as Gaussian elimination method. No? This will be taken up in linear algebra 1. So, if we have this equation here, we're given 3 equations in 3 variables. The first equation is 3x plus y plus z is equal to 2, x plus y plus z is equal to 0. And 5x minus 2y plus 3z is equal to negative 8. So we now have these 3 equations on the system of equations here. First, we are going to rewrite the system of equation to its augmented matrix form. So in doing that, we just copy all the literal numerical coefficients, of each equation here. No? So if we just copy this one, the numerical coefficients, we will have this augmented matrix form of the system of equation. No? So the first one is the coefficient is 3, 1, 1, and 2. No? And the second one is 1, 1, 1, and 0. The third one is 5, negative 2, plus 3, and negative 8. So this now will be our augmented matrix form of the system of equation. So now, the principle behind this is to arrange this in such a way that the resulting equation will be easily used to solve the new equation. So if we have this equation now, this augmented matrix form, we arrange this one in such a way that the first leading coefficient is 1, and the second column and second row will be 1, and the third row should be 1, as much as possible. But before arriving into the row echelon form, which we will have 0, 0 here, we can easily digest that the equations that we are dealing with can now be used to solve the equation. So if we have this now equation here, as you can see, we will just to have this leading one coefficient here, we just interchange the equation here, or the coefficients here, the row 1 and the row 2. After interchanging this, we have this new arrangements, augmented form. We have here 1, 1, 1, and 0. We just we row 1, interchange it with row 2. We have here 1, 1, 1, 0. This one should be written in the second row, 3, 1, 1, and 2. And we don't touch this third row. We have here 5, negative 2, 3, and negative 8. We now have a different arrangement. Now, for the next process, we will multiply row 1 by negative 2 and add that to row 3, and the answer should be written in row 3. So negative 2 times row 1 will be negative 2 plus 3 is 1. I mean this one here. Negative 1 times negative 2 is negative 2 plus 5 is 3. 1 times negative 2 plus 2 negative 2 is negative 4. 1 times negative 2 is negative 2 plus 3 is 1. 0 times negative 2 plus 0 times negative 2 is 0, plus negative 8 is negative 8. So we now have a new arrangement of the augmented matrix form of the equation. So next, we are going to subtract row 3 to row 2. This is our row 3. 3 times 3, 3 minus 3 is 0. we write the answer in the third row, no? -4 minus minus 1 is -5. -4, I mean, so in 3, no, row 3. 1 minus 1 is 0. Okay? -8 minus 2 is -10. So we now, again, we change the whole system here, having 1, 1, 1, 0, 3, 1, 1, 2, 0, -5, 0, and -10. If we will study this carefully, we can see that the third row here has only one variable left, no? That is y, no? So next is we are going to subtract, no? Row 1 to row 2, no? And put our answers or our answer to the row 2, no? So we have here 3 minus 1 is 2, 1 minus 1 is 0, 1 minus 1 is 0, 2 minus 0 is 2. So this is our next system equation, or next augmented matrix form. Now we study this one carefully again. For row 3, we have here only one coefficient for one variable, that is y, and this one is for x, no? Solving for each variable using the back substitution, no? -5y is equal to -10. Solving for y, we have here -5y, -10. We will arrive at y is equal to 2. And this one, 2x is equal to 2, x will be equal to 1. Having these two variables here solved, x is equal to 1 and y is equal to 2, we just substitute this one into the equation 1, no? So this one is 1, x plus y plus z is equal to 0, x is equal to 1, and y is equal to, we have here, positive 3 plus z is equal to 0. Solving for the value of z, we will arrive at z is equal to -3. So that's how we're going to apply the Gaussian elimination method, no? Or the Gauss's elimination method. So we have here another problem for linear algebra. In this case, we have here, x minus z is equal to 0, 3x plus y is equal to 1, -x plus y plus z is equal to 4. So again, we're going to rewrite this into its augmented matrix form, copying only the numerical coefficients of each equation. We have here 1, 0 for y, no? We supply, no? The missing variable, we supply 0 for the missing variable. So 1, 0, -1 for z is equal to 0. For the second equation, we have here 3, 1, 0, and 1. And lastly is -1, 1, 1, and 4. Having this system here, we are going to subtract, no? I mean add. Excuse me. We add row 1 to row 1 to row 4, no? I mean to row 3. This is row 3, no? So 1 plus negative 1 is 0. No? 0 plus 1 is 1. Negative 1 plus 0 is... negative 1 plus 1 is 0. 0 plus 4 is 4. No? This is row 3, I mean. No? This should be row 3. So using back substitution from row 3, no, this is, as you examine this carefully, we have here for row 3 we have only one variable left, which is y. No, y is equal to 4. So using this back substitution for using y is equal to 4, we have here from row 2 3x plus y is equal to 3. So we substitute the value of y, which is 4. We have here 3x plus 4 is equal to 1. So 3x is equal to negative 3 by transposing 4 to the right side of the equation. We have 3x plus is equal to negative 3. So x will now be equal to negative 1. From 1, we have x minus z is equal to 0. And knowing x is equal to negative 1 minus z is equal to 0, we add 1 to both sides of the equation. We have here negative z is equal to 1. No? So z will now be equal to negative 1. So we now have all the values for 3 variables. X is equal to negative 1, y is equal to 4, and z is equal to negative 1. So constant practice of this Gaussian eliminated method will be able to solve any system of equations involving 2, 3, or more variables. So thank you again for watching our videos for today. And please don't forget to subscribe to my YouTube channel by Wilfredo Tan. And if ever you have any suggestions, we just send it to us by means of Tagalog or English, no? So that we can improve our way of presentation. Thank you, and see you again later.